Good morning, students. I am going to explain the last chapter, radioactivity. So, what is radioactivity in simple language? We can say it is a nuclear phenomenon in which some radioactive substances emits some rays named as alpha, beta, gamma. Why is it take place? Why is it happening? We will discuss everything later on. Before we start the main portion of the chapter radioactivity, let me discuss about the structure of atom and nucleus. You know that atom consists of three particles: protons, neutrons, electrons. Protons and neutrons are combinedly packed in nucleus. They are called nucleons, right? Whereas electrons move all around the nucleus, and all the electrons do not move in a particular orbit. They revolves around the nucleus in different orbits according to their energy level, right? So simply you can say that atom consists of three particles: protons, neutrons, electrons. Proton, neutrons are combinedly packed in a nucleus called nucleons, whereas electrons revolve around the nucleus. Now if we look at, say, for element X, here A, Z, normally we represent an atom in this way, where X is the name of the element and A is the mass number. What is mass number? It is the total of protons and neutrons in a nucleus. Mass number represents the total number of protons and neutrons present in a nucleus, whereas Z is the atomic number. Z is the atomic number which represents the number of protons in nucleus or in an atom. Example, say sodium is a common element, sodium 2311. Here 23 is mass number and 11 is the atomic number. So that means since atomic number 11, number of protons here 11. And as you know, in an atom, number of protons and electrons are same, because an atom is electrically neutral. So proton number 11, electron also 11, and number of neutrons will be 23 minus 11 equals to 12. So in short we can say sodium has 11 protons, 11 electrons, and 23 minus 11 equals to 12 is the number of neutrons, right? So we have discussed so far mass number, atomic number. So atomic model, if you look at here for sodium atomic model, we will see there will be nucleus, here 12 neutrons and 11 protons, and the 11 electrons are there, but they will not revolve in a particular orbit. They will be revolving in different orbits. As you know, in chemistry the named are K, L, M. So in K cell there will be 2 electrons maximum, in L cell there will be 8 electrons maximum. So 2 plus 8, already 10 gone. So 11 electrons are there, only 1 electron is left in the M cell, right? In chemistry we talk about this electron. This electron is called free electrons or valence electron, okay? Now we will talk about some important terms. In important terms, let me discuss first isotopes. So what is isotope? Isotopes are the atoms of the same element having same atomic number. Atoms of same element having same atomic number but different mass number. Example, hydrogen. It is the ordinary hydrogen. So this is ordinary hydrogen, this is deuterium, and this is tritium. See here, everywhere the atomic number is 1, but the mass number here 1, here 2, here 3. There are some more isotopes, like say oxygen 8, 16, 17, Okay, so mass number are different but atomic numbers are same, so they are called isotopes. Similarly, we will see there are other terms, isobars, isotones, etc. Okay, now here in this term we will talk about the radioactivity. What is radioactivity? It is a nuclear phenomenon in which the nuclear substances spontaneously emits alpha, beta, gamma radiations from their nucleus. What are the radioactive substances? As for example, we can say uranium, thorium, plutonium, radon. All are the radioactive substances. They spontaneously emits alpha, beta, gamma radiations. There are some radioactive substances which has the atomic number quite less. So thorium, radium, plutonium, radon, all are having the atomic number more than 82. But there are some elements or isotopes, we can say in simple way, whose atomic number is lesser than 82. Even then they are radioactive in nature. They are so called radioisotopes. Example, carbon 14(6), sodium 24(11). These are the carbon, this is carbon radioisotopes, this is sodium radioisotopes. See, their atomic number much lesser than 82. It is 6, it is 11. Even then they are radioactive in nature. So these are called radioisotopes. They have so many uses: industrial uses, scientific uses, and medicinal or medical uses. Okay. Now we will talk about the emission of alpha, beta, and gamma rays. This type of experiment first introduced by scientist Rutherford. That's how we can say it is also named as Rutherford experiment. In Rutherford experiment, we have seen that some radioactive substances are kept in thick lead tube having a narrow hole. So through this narrow hole, we will see all the radiations come out. Now, all this radiation, whatever comes out, if we keep in a field, either magnetic field or electric field. I have kept here an electric field. If we allow the radiations coming out from the radioactive substance passing through an electric field, we will see that radiations or whatever comes out, means emitting particles, are not in one. They are now separated from each other. Okay. Why they are separating from each other, we will discuss here only. So if you keep a magnetic field, here positive plate and here negative plate. So in between these two plates there is a electric field. So when radiations coming out from the radioactive substance, this is radioactive substance, we will see the emitting particles are not coming together. They are separated from each other. One part we will see it bends towards the positive plate, little bending more. So since it is bending towards the positive plate, so definitely it is negatively charged, and this negatively charged is called beta particles, right? Similarly, we can say one part is bending towards the negative plate. Definitely this part has positive charge. So this is named as alpha particle. And third part, which is unaffected due to the electric field, it is undeviated, unaffected. So it goes straight. That is called gamma rays or gamma emission. So we have seen alpha, beta, gamma emissions or rays. So from here we can get the properties of alpha, beta and gamma. So in short, I can say beta particles, negatively charged particle, and since it is lighter, it bends more. Okay, and in case of alpha particle, being positively charged, it bends towards the negative plate, and since alpha particles are heavy, that's why it bends less. And since gamma particle or gamma emission or gamma rays are not affected at all by electric field, or we can say by magnetic field, we will see it is uncharged, means it has no charge, like electromagnetic wave. It has no mass, no charge. It is more or less electromagnetic wave like light rays. Okay. So from here we can study or we can think of the properties of alpha, beta and gamma radiations. Now we will go for the last topic, changes within the nucleus. Before we start the changes within the nucleus, let me talk about little bit about beta. So what is beta particle? Beta particle is nothing but fast moving electrons. Fast moving electrons. So symbolically we can say it is this. Beta particle is nothing but fast moving electrons which comes out from the nucleus. How is it possible? Look at here. One neutron has mass 1, no charge, gives out a proton plus beta particle, and this beta particle is nothing but E0 minus 1. So if you look at the balancing, you will see 0, 1 minus 1 equals to 0, 1 plus 0 equals to 1. So you see, so we can say in simple way, beta particles are nothing but fast moving electrons which comes out from the nucleus. When a neutron converting into proton, it gives out beta particles. Okay. Similarly, you can say what is alpha particle? Alpha particle is nothing but helium nucleus. Helium nucleus. In an helium atom, we have seen 2 protons, 2 neutrons, and all around the nucleus in the K cell there are 2 electrons. So this is helium atom. This is helium atom. Now if you remove these electrons from the atom of helium, then we will see only nucleus is left. So this nucleus is nothing but so called alpha particle, and it is written as He42. He42 means 4 mass number. Mass number means 2 protons, 2 neutrons, and 2 means 2 protons, right? So alpha particle is nothing but helium particles, or sorry, helium nucleus. Okay, consists of 2 protons and 2 neutrons. And as you know, we have already discussed, gamma rays has no mass, no charge. That's why we can say when gamma ray comes out, there is no change of mass number or atomic number. Now we will discuss in details about the changes within the nucleus. So first I will talk about alpha emission, or we can say alpha decay. So as we have talked about, alpha particles are nothing but helium nucleus. So if you look at a general conception, suppose there is one general equation, X is the name of the element, has mass number A, atomic number Z, is converting into Y. This X is called parent nucleus, and this Y is called daughter nucleus. Daughter nucleus. We are not talking about atom, we are talking about in case of radioactivity, all the time we will talk about nucleus, not atom. So we will be talking about nucleus, here also nucleus, right? This is parent nucleus, this is daughter nucleus, and gives out one alpha particle. And as you know, alpha particle is nothing but we can say helium-4, 2. Now if you will balance it, here A and here mass number will reduce by 4, so it will be A minus 4. Okay. Similarly, here atomic number Z, so Z will be reduced by 2, means atomic number will be reduced by 2. So atomic number will be Z minus 2, right? So what you have seen here, X is the parent nucleus, mass number A and atomic number Z. When liberating one alpha particle, we have seen the nucleus become Y, daughter nucleus, and mass number is reduced by 4, so mass number becomes A minus 4, and atomic number is reduced by 2, so it is Z minus 2. Exactly we can say one equation, uranium 23892. It is one of the isotope of uranium. When it gives out thorium, one alpha particle, He42, then we can within bracket you can write alpha particle. Then if you balance, you will find 238 minus 4 is equal to 234, and 92 minus 2 is equal to 90. Look at in reverse way. Uranium atomic number 92, mass number 238, gives out alpha particles, so atomic number is reduced by 2, becomes 90, and mass number is reduced by 4, becomes 234. There are so many as such equations you can learn from the textbook, or at least you keep in mind one equation, right? Okay. Now we will go for beta emission or beta decay. What is told before? Beta particle is nothing but fast moving electrons which comes out from the nucleus from neutron. When one neutron is converting into proton, it gives out an emission of beta particle. Okay, so now let me discuss here some example. Before we go for example, let me discuss on general equation. Again, atomic number Z, mass number A of the parent nucleus, daughter nucleus Y, this is parent nucleus and this is daughter nucleus. So giving out beta particle, we can say E0 minus 1. If you don't write E0 minus 1, only if you write beta particle also will do. But why I am writing 0 and minus, so that you can understand very easily how to get the atomic number as well as mass number for daughter nucleus. So here mass number will remain same, because mass number of beta particle means E is 0. So mass number remain same, right? Now look at here in case of atomic number, interesting. For atomic number Z here, it will be how much? Now look at when the Z is beta particle has atomic number minus 1, charge is minus 1, so atomic number will be Z plus 1. Yes, it is Z plus 1. Look at the equation, balance the equation, you will see here A plus 0 equals to A, here Z plus 1 plus minus 1. So Z plus 1 plus minus 1 is equal to Z. So atomic number also remains same. So we can say one parent nucleus liberating beta particle, mass number remains same, atomic number is increased by 1. If 2 beta particle comes out, then we can say atomic number will be increased by 2, right? I am giving real example in case of say carbon 14(6). It is one of the radioisotope of carbon. When it gives out one beta particle E0 minus 1, see here the mass number will remain same 14 and atomic number 6 here, so it will be here 6 plus 1 7. So I wrote little different way. Here mass number of carbon isotope is 14 and atomic number 6. Mass number will remain same. Okay, 14 plus 0, 14 only, and atomic number will increase from 6 to 7 as you have seen in this case. So here 7. So can you guess one element whose atomic number 7 and mass number 14? Yes, it is nitrogen. So here parent nucleus carbon becomes nitrogen. I can give one or two example more. In case of sodium 1124. Yes, it is also one of the radioisotope of sodium. Gives out one beta particle. E0 minus 1. So here atomic number will be increased by 12. Sorry, atomic number is increased by 1, becomes 12, and mass number remains same, 24. So can you guess what is it? Yes, it is magnesium. So magnesium mass number 24 and atomic number 12. So we can say here sodium becomes magnesium when it gives out one beta particles. Now we will go for gamma emission. So here general formula X, Z, A, and gives out one gamma emission or gamma particle. As I talked about, gamma has no charge, no mass, so everything is zero as such. So we will see the mass number does not change. So A remain A and atomic number also remains same. Here this X is called parent nucleus and this X is called daughter nucleus. Since mass number remains same, Z also same, means atomic number also same, so nucleus also remains same. This is called parent nucleus, this is called daughter nucleus. But one thing, how is it possible? Though there is no change, even then gamma is coming out. So we can say gamma emission takes place either parent nucleus or daughter nucleus is in excited state. Excited state means suppose one atom has some energy. If due to some reason that nucleus has more energy than the stable formation, then we can say it is in excited state. And in case of excited state, we will see the gamma emission takes place. So we can say either parent nucleus or daughter nucleus is in excited state. So for this excited state, I can say one asterisk mark. This asterisk mark shows that here parent nucleus is in excited state. If this asterisk mark come here, we can say daughter is in excited state. So I can say, or we can conclude here that gamma emission takes place either parent nucleus or daughter nucleus is in excited state. Okay, so I have discussed more or less everything. Even then, if you have doubt, please contact me. Thank you so much.